So, really this is just another tool in your toolkit to do some type of dimension reduction on text and to make sense of text, unstructured text in an unsupervised manner. Whereas topic modeling, we're approaching things from a Bayesian and probabilistic approach. Here we're using the tools of graph theory or network analysis and associated community detection algorithms to pull out meanings in text. So before we get into it too much, because there are likely some people out there for whom this type of network or graph theory terminology is new, I'm just going to go over a few fundamentals. So a network is usually defined as a set of nodes as well as their connections or edges to each other. Sometimes nodes are called vertices, sometimes edges are called ties, but the fundamental idea is that we can represent any type of relationship between units as a network. So for our purposes, we often talk about, as social scientists, we often talk about social networks as connecting people. So let's say we could pretend this was a visual representation of emerging friendships between people in this room, right? And we're seeing now that there's some natural communities that are emerging, right? There's this green group, the red group, and the blue group. And we could say, well, maybe the green group is people studying crime, and the red group is the people who are interested in health, and so on and so forth, right? But the idea is that we're able to group things, in this case people, by patterns in their association with each other. And we do that, practically speaking, using a lot of math from the field of community detection. One thing that's interesting, though, is we can make a conceptual shift. We can begin to think of people as connected to each other, or people as being connected to each other by doing a similar behavior. For example, talking about the same things. So we can start to think about representing human language either by detecting similarities in the ways people speak, or by looking at similarities across documents that are produced by different people. Let me give you an example. I know that's not immediately super intuitive. Here we have a visual representation of newspapers on the day of the moon landing in the 1960s. Sorry, I can't blow this up. So we've got here the Washington Post, we've got the Guardian, we've got the Boston Globe, the LA Times, the New York Times, and so on and so forth. And so we've got each newspaper represented as a square here. But then in these circles here are the first 10 words that the newspaper article used to describe that event. So, the New York Times is saying, Armstrong is collecting rock from the land. The Boston Globe is talking about one small step for mankind, and so on and so forth. And what we might want to do is say, okay, well, how did different newspapers talk about the moon landing? Which ones were most similar? And that would be one way of drawing a network. And in that case, we would look at all the entire set of words produced by each newspaper, and then use some type of NLP to describe similarities in the strength of connection between any two newspapers. Or we can do the opposite and look at the words themselves and think, and this is more like topic modeling, we can think about trying to detect groupings of words that cohere into topics. So we can either have an author-based projection of a text network or a word-based projection of a text network. And we might want to use author-based if we're trying to describe how similar people are, and we might want to use word-based projection if we're trying to describe how similarly people group different types of words together into abstract categories like text. So what we're going to do is transform what's called a two-mode network, which describes multiple types of human networks at the same time, into a one-mode network, either by collapsing the newspapers together in this case, or the words together. Once we have that network, then we can use a variety of community detection techniques which have some nice properties that arguably provide some advantages over topic modeling that capture some of the tendencies of human language, and that can also be used for shorter text, and that can also be used to capture dynamic properties of text. So I'll talk a little bit more about that as I go along. So here's an example of the word-based projection of a text network. where we're grouping words to how often they occurred across newspapers. And here's the newspaper-based projection, where we're grouping newspapers based on how similarly they talked about the moon landing. So how do we get from words to networks? This is from a paper I wrote some years ago. Basically, what we do is we get a corpus. We could create a tidy text corpus. We could create a corpus object. We could use any of the data management structures we talked about. And if you're following along online on your laptop there, you'll see these are 3 Facebook posts by 3 different nonprofit organizations. And the first step we use in Textnets, which is the package that and software that I've developed, is to try to pull out what we think are the most meaningful words from any corpus. We use a tool called UDPipe, which does sentence parsing and allows us to pull out proper nouns and named entities, and also allows us to distinguish different parts of speech. So remember earlier when we were beginning to worry about sequences of words and whether those might, if we broke words up into singular bags of words, that those might distort the meaning of words in sequences? Well, if you have a term like the United States of America, instead of being broken up into United States of America, you can capture one string and run an analysis on that. And the way we do that in the package that I'll show you is to use another backend or another type of software that lives somewhere else for splicing up text into its constituent parts. So the first thing we do is we pull out nouns and noun phrases, which we think hold the topical content of a post most reliably. You could make an argument that adjectives are important if you wanted to capture sentiment, and I'm going to show you an extension of Textnet at the very end that combines both nouns and adjectives to try to capture both topics and sentiment in a single graph representation in something called a valued network, but that's still in development for now. So basically what we do is we isolate what we think are these meaningful words, noun phrases or sequences of named entities and other nouns, and then we calculate the metric I was talking about in the previous lecture, the term frequency, inverse document frequency. These are the weird words that occur most uniquely in one document across the whole corpus. And from there, we can pull out the weird sounding words. So these are Facebook posts about autism spectrum disorders. And as you might imagine, nearly every organization in this field of discourse talks about autism. So autism has a very low TF-IDF. It's a relatively common term. But terms like neurodiversity, which describes the belief that autism results from underlying natural variation in the human genome and not some kind of pathology that can be solved, is a very unique word that is not used all that often. And so that means that if any 2 groups use a word that is very similar, we can assign them a very weak relationship to each other by summing up the TF-IDF of the overlapping words any two authors use, or we can give them a stronger relationship if they both use unusual words. In this case, 2 of these groups are using the term vaccines, sorry. So basically, once we do that, we begin to work from unstructured text to a network-based representation of text. And here we describe this as a weighted network because instead of just describing the presence or absence of ties between 2, or now we're talking about organizations, we could be talking about people or newspapers, as I was talking about earlier. Now each connection between people has a strength. And this is commonly referred to as a weighted network in network analysis. Okay. Any questions so far? We've been over a lot in a short amount of time. No? Okay. So now we can do some fun things. So this is a paper written by Elise Roule, Jean-Philippe Cointet, and Peter Bierman, which uses text networks to identify word communities in State of the Union speeches by U.S. presidents. So every year the U.S. president gives a speech about the State of the Union, and basically here they've created, out of that large data set, which we're about to work with too, they've pulled out nouns and noun phrases, and they've created connections between words that occur very often alongside each other. So I was just talking about a author-based projection. This is the opposite, the word-based projection. So here they're looking at words independent of who spoke them, and they're connecting words if more than one author used them. And the idea here is that we can then start to see topics emerge from communities in this word-based graph representation. And what's nice here is, unlike topic modeling where a lot of the words are kind of hiding under the hood and we can try to guess which words are important, we can very quickly see in a visual space which words are comprising each topic, and perhaps even more importantly, which words are in between multiple topics, or which words bridge topics, which allows us a new kind of way of understanding how confident we should be in our categorizations. And I'll show you some tools that you can use to produce interactive and JavaScript visualizations within your browser of a text network in just a minute using my Textnets package. Okay. These things are also dynamic. This is a stream graph or a river graph or a Sankey plot, whatever you want to call it, of the distribution of topics in network communities over time from the same paper I just mentioned. And this is a way of capturing the dynamism of the fields. Here we're chunking up networks by decade. And you can see how topics come in and out of the discourse in American politics. And if we want to try to, if you want to get this up and running on your own, I've created a software called Textnets. It's an R package. And it has tools to prepare text for network analysis, does all of the kind of pre-processing steps and cleaning steps we've been talking about, almost all the cleaning steps, doesn't handle things like character encoding. And then it creates a text network, which means it takes that unstructured text and it turns it into what's known as an adjacency matrix. This is similar to a document term matrix, except instead of having documents on the as rows and words that appear in any document as columns, you instead have a square matrix. Either the rows and columns are people and the cells describe the overlapping sum of the term frequency inverse document frequency for the intersecting set of words that they jointly use, or you have a square data frame that describes every word that appears in the corpus and how many people both use those words. And either way, you create a matrix representation of text. It's a different matrix representation than the document term matrix we described earlier. It's what you might call an adjacency matrix. So there's a tool for creating that step. There's a function for visualizing the networks, both in a static way and in an interactive JavaScript way. And finally, there's tools for detecting themes in the text and pulling out the relevant terms. Right now, the package is still on GitHub. We've been trying to assemble the person power to move it to CRAN, but for now, you'll have to install it from GitHub if you want to try it out. To install an R package from GitHub, you'll need a package called DevTools or Development Tools. So you need to install DevTools, load DevTools, and then use the install_GitHub package to install Textnets. Or if you wanted to install someone else's package, you just put their username and then the name of their repository. You should do this with some caution, generally speaking, because pretty much anything could live on GitHub. And some of us in the R community concerned about how the open source nature of our field could lead someone to kind of put a Trojan horse in there. But I can tell you, having written this one, there's hopefully nothing unsafe about this one. Hopefully. But really, anytime we install any open source software, it could happen. And the official review process is supposed to catch these things, but it might not, especially as we begin to pipe things to APIs left and right. We don't know where our data is going very often, as well as we probably should. Okay, so Textnets ships with the data we were just looking at, this state of the union addresses. So if you use this data function, it will load a data frame in your R session. And each row of the data frame is going to be a year, a president, and then the entire text of that speech. And here we're just grouping by president because we're going to create an author-based projection. We're going to connect presidents based on their tendency to use the same words and the same unique words together. We're just using some dplyr here to do that. And the workhorse function of the Textnets package is this, or one of the two, is the prep text function. So here we pass a data frame. We have a grouping variable. That's the actors we want to use here in this case. We can choose either groups or words. That defines whether we're doing an author-based or word-based production. All this is carefully documented in the annotated code linked on our slides today. We can tokenize by words or n-grams or sentences. And we can keep different parts of speech. Here we've kept nouns and we've removed stop words, and we've kept compound nouns. These are the type of sequences like United States of America that we think would capture more meaning in this case. The create TextNet takes that queen data, that's actually tidy text data, and then turns it into the adjacency matrix I just described, the weighted network. And the viz TextNet package creates a gggraph representation of that space. So here we're seeing the presidents of the United States grouped by time period according to similarities in the ways that they talk about the state of the nation. Here we have this parameter allows you to determine whether every node should be labeled or just loads that have at least one connection to someone else. So very often in networks and text networks, we get a very dense network because many people have at least some shared language with other people. And by default, we use something called a network backbone technique to prune the network. I'll show you a parameter that does that in just a minute. The interactive JavaScript visualization, I'll show you just two more things before we wrap up for lunch, requires this HTML widgets package in order to save it. But if you want to just visualize it within your browser, here you'll see, I think we're missing that visualization. Oh, here it is. So here you can mouse over any node, reveal the name of the actor, and look at the ties and the strength of ties between them. And this, if you wanted to save this and say host it on your web page, you could use the HTML widget that I just showed you to do that. And finally, I also want to mention this important alpha parameter, which we've added. This describes the cut point or the density of the graph. So by default, this has a value of 0.2. If we make this less, more ties between people will be revealed. Why do we typically hide those? Because we don't want to reward ties between people who are all using very common words. So the fact that all presidents use the United States of America in their speeches should probably not matter, right? So if we want to reveal all those, we could set our alpha to 0 and we'd see all the connections and the strength of connections between people. But if we want to use the a more stringent criterion, we might use somewhat arbitrarily 0.25. And the colors of the nodes here are being created by something called the Louvain community detection approach that if you read the documentation, it will explain how we use fairly sophisticated mathematical algorithms to group either authors or groups of words. Here I'm showing you how to validate your topics, pull out top words. We're using lemmatization, which is a more sophisticated technique than stemming, which I mentioned earlier, which looks at some of the more complicated syntactic relationships between words. You also see that our tokenization strategy captures things like recovery plan, which would have been separately by a bag of words approach or a unigram approach. And we can also use the core methods of network analysis to further try to figure out what are the most influential words in our network. So for example, I have a paper that shows that nonprofit organizations that use words that are at the center of a discursive network that bridge multiple types of discussions are more likely to generate larger, more viral conversations on social media. And finally, just to wrap up, because we've got to get to Jen Pan's talk in 10 minutes or so and get our lunch before that, we're doing an extension of Textnets where we have not only nodes grouped according to communities, but now we begin to connect the nodes based upon their shared sentiment towards the word. So we use adjacencies in word structures and sentence parsing to determine whether people share the same sentiment towards the same object or noun. And that allows us to create a valued graph, which then allows us to create groupings of people not just based on similarities in the topics that they're talking about, but on the way that they're talking about those topics. So it's kind of like you can almost imagine it as combining sentiment analysis and topic analysis and topic modeling, but within a network-based framework. Okay, so we'll wrap up there. I'm happy to take questions on the Slack. I think we better not take questions now in order to get our lunch. And for those of you on the live stream, I'll be on Slack for the next 20 or 30 minutes answering any questions you have. Thank you very much.